Saxon's Trig, lesson 84, is about factorable expressions and then sketching sinusoids. So in part A, when they do the factorable expressions, they remind you just a few of the different ways that you can factor something. So if you were given a sine cubed x, that can split into a single sine x multiplying with a sine squared x, a tangent squared theta minus 1 can split into two parentheses. The tangent squared goes to tangent theta and tangent theta. There's no middle term, which means one will be positive, one will be negative, and the 1 splits into 1, and the final double check, positive times negative is negative, so it is factorable into two parentheses. If you have 1 minus tangent squared theta, it's going to work very similarly to factor into two parentheses. The 1 goes to 1 and 1, no middle term, so 1 positive, 1 negative, the tangent squared going to tangent theta, and then double checking, positive times negative is negative, okay. Cosecant squared x minus 1, same concept. So cosecant x and cosecant x, positive and negative, no middle term, 1 and 1, positive times negative, negative, we're good. Then they do, thankfully they shift gears a tad here, so we have sine x minus sine x multiplying with cosine squared x, and because both have a sine, you can pull out a sine x, and that leaves you with nothing here, so I need a placeholder of a 1 for distributing back purposes, so sine times 1 would give me the sine x minus, and since I pulled the sine out, all I have here is the cosine squared x. Oh, looky, this one can do the same thing we were doing here and actually split again, although in the book they leave it in this format, but this can become sine x with 1 plus cosine x and 1 minus cosine x, and that's also the same factoring as that. What else did they give us? Okay, if you have a cosecant to the 4th p, they've changed gears, minus cotangent to the 4th p, you can split that into halved for both. So cosecant and half of 4 is squared p, cosecant squared p, because when you multiply those together, you get the 4, 1 positive, 1 negative, because there's no middle term, and then the same cotangent squared p, sorry, that one's crammed, cotangent squared p, positive times negative is the negative. And then this one, let's see, could you factor that any further? Yes, because you have no middle term, you have a negative, you could make it cosecant and cotangent, one with positive, one with negative. So that can factor even further. All right, they then do 1 minus 2 sine squared x plus sine to the 4th x. This has 3 terms. So when I go to split it into 2, this is written backwards, so I'm actually factoring sine to the 4th minus 2 sine squared plus 1. So the front thing would be this sine to the 4th, although they still kept it in this order. I'm going to match what they're doing. Technically, this is the first one, and I would write it first, however. But 1 can split to 1 times 1 is still 1. I have no idea what the signs are because I have a middle term. The sine to the 4th can go to sine squared x and sine squared x. That makes sine to the 4th. It's positive, so now I know my choices are either both positive or both negative. Now, how do I know? I look at the sign in the middle, and if it has to be a negative, then both of these have to be negative. Now, to double check myself, 1 times this makes negative sine squared. Doubling with another one, another negative sine squared. Yep, that is negative 2 sine squared. So there's the factoring for that one. And then they give us sine cubed x minus cosine cubed x. And yeah, they have not given you this factoring. We're actually going to learn this one upcoming. So don't panic that you don't understand where this comes from. I will give it to you later, and there's a very long pattern here. And so if I pull a single sine and a single cosine out, this is going to be sine squared x, and then my middle term plus sine x cosine x. Again, don't worry that you don't know where that came from. Last one's always a positive, and then there were cosine squared x left over from the cosine cubed at the beginning. Okay, so it says the last two were especially tricky because they must be recognized as having the same form as something else. So again, maybe this one you're not as familiar with either. Okay, now that we've gone through that lovely review, they go into example 1. Show, so again, I want to manipulate the first half and make it match the second half. So sine x minus sine x cosine squared x equals sine cubed x. All right, so I see that I've got a sine in both, so I'm going to be doing this where I've pulled it out. So since we've already done that work, let's write this as, oops, wait a minute, sine x with 1 minus cosine squared x. And what is 1 minus cosine squared x? Oh, remember that 3 that we had at the beginning where we had sine, or just a couple lessons ago, not beginning, sine squared x plus cosine squared x equaled 1. So if I rearrange this and make it 1 minus cosine squared, oh, look, that's a sine squared. So what I have is sine x multiplying with sine squared x, and what does that give me? Sine cubed x. That's what they wanted, and I can check mark it. Example 2. Show secant to the 4th minus tangent to the 4th. And again, I've started my bad habit of leaving the x off on that. Secant squared plus tangent squared plus tangent squared equals secant squared. All right, so I've got in the numerator secant 4 and tangent 4, which I can split into secant squared, no middle term, 1 positive, 1 negative. Tangent 4 goes to tangent squared, and just as a triple check, positive times negative is negative. Wonderful. On the bottom, I have a secant squared plus tangent squared. Now, if this had been a minus, I could have factored it, but it's not, it's a plus. So I'm just gonna write it as a unit and realize immediately that it matches this one, so it can cross off. How beautiful. Plus tangent squared. Secant squared, so I have no denominator anymore. Secant squared minus tangent squared plus tangent squared. Oh, minus and a plus, they cancel. That just leaves me with secant squared, and I should put that letter back, x. And yep, that's what they wanted me to prove. Example 3. Cosecant squared minus 1 over tangent, and they want me to show it equals cotangent cubed. All right, so my cosecant squared minus 1, I want to factor, so, oops, let's leave a little more space. So let's go with cosecant, no middle term, 1 positive, 1 negative, 1 splits to 1 and 1, and positive times negative is negative, great. Tangent, let's go ahead and put it in its sine over cosine form. And can I do anything with that factoring? No. So the factoring did not help, because I'm stuck. There's nothing much I can do with that. So sometimes I try something, looks like it's going to be a good start, and I realize, nope, I got stuck. So then I backtrack and I look again. Is cosecant squared minus 1 one of those memorized facts? Yes, and so I can substitute it for, make sure I'm not, they did not change it to sine over cosine. That's not helping. Okay, yes. So this is cotangent squared. If you remember, or looking back in your notes, so cotangent squared over tangent. I can leave it that way. Nope, I'm going to go ahead and change it over to its sine over cosine form. I just prefer to work that way, even though it might actually cost me a little more. So now my cotangent is the opposite of that. So it's cosine squared over sine squared. And then this one flips when it comes up and is no longer dividing as the fraction. So it becomes cosine over sine, which now means the numerator is cosine cubed and the bottom is sine cubed. And let's see. Yes, and did I, oh yes, I was looking for what was I heading to? Here is what I'm heading to. Is cosine over sine the opposite of tangent? Well, tangent was sine over cosine, so yes, cosine over sine is cotangent, and it is in its cubed form. So this does equal cotangent cubed. What was my letter? X. Okay, and then my check mark, yes, I have proved it. All right, part B completely changes gears and goes to sinusoids and the sketching of them. So now they're going to give you an equation, plus 2 sine 3 parenthesis x minus 45 degrees. And they say we're sketching it. So we know we're going to have our curvatures. Our center line is going to be at -10. Our high point and our low point are 2 above and below. So -8 and -12. Sine tells me that I'm starting in the center. And I see that I have a shift, which I'll come back to. But my starting place should be at positive 45 degrees. Because I pulled it out of the parenthesis, I change it. Now I know I'm starting in the center. This was positive, so I know I'm going up first. I know I should have 4 sections, always. And I started to say I should add 360 with 45 to get my end spot, but remember I had a 3 here that was changing that period. So before, what we did was we did 360 divided by whatever this was in, and that's how we got the 3. So we basically need to undo that, or consider the fact that by the time I get to 360, I will have done 3 complete patterns. I can at this point pause and do that. But rather than trying to figure out the degrees based on 3 full curves happening here, I'm going to take the 360 and I'm going to divide it by this given 3, which tells me that each curve section for the circle should occur in 120 degrees. So all of this is 120, but I started at 45. So I'm going to end at 165 degrees here. Technically the curve continues on both directions. It's going to go down here and continue this way, but I tend to only sketch 1 rotation of the circle for the sketch of the sinusoids. All right, let's do example 5. Sketch the graph of y equals -2 plus 4 cosine 2, and then x plus 2 pi over 3. So this one is given in radian, not in degree. Makes it a little harder to label. So I know my center line is at -2. My height is 4 things above and 4 things below. which would be 2, and this would be -6. Cosine means I'm either starting above or below. This is a positive, so I know I will be starting above at the 2. However, I'm not beginning at 0. I'm beginning at negative, pulling out of the parenthesis. I'm going to jot this for a second. I'll try to explain why. -2 pi over 3. Now, I have trouble thinking in radian, so I want to just mentally change this over to radian. 3 goes in here 60 times, so this is -120 degrees. So that I now know, because I can't visualize where -2 pi over 3 is, although that's what I need to label it. I get a feel that my -120 is a little further back. It's not super close here to the 0. So the likelihood is I will have another section here in the negatives. I just don't know what it is yet. But we're going to label our starting place then at -2 pi over 3. And I said it had to start up above because this was positive and it was cosine. Now, I need my 4 sections. I could have 1 section in the positives and 3 in the negatives and 3 more in the positives. I could have 2 here, 2 here. I could have 3 here, 1 here. I just don't know yet. But I am going to go ahead and take 2 pi being the full amount and divide it by the 2 to get how many degrees my 4 sections should fall in. So that is actually pi. And I don't have to convert because I know that pi is 180 degrees. So I'm adding pi to this starting place of -2 pi over 3. And when I add that with pi, common denominator makes it 3 and 3. So I know that where it ends is going to be at 1 pi over 3 or pi over 3. So wherever that section is ending is going to be pi over 3. I know that's in the positive section. Okay, and I still need 4, but I don't know where they're falling. So we're going to take our 2 pi, which is the 4 sections, and we are going to divide it into the 4 sections. So how many is that? That's a half a pi each time. Okay, so I know it's time consuming to work in radians, but -2 pi over 3 is my start, plus a half a pi or pi over 2. Common denominator is 6, so this one makes -4, this one makes 3. -4 plus 3 is -pi over 6. Oh, so my next one is still in the negatives, -pi over 6. Okay, take that one, add the pi over 2, common denominator 6, 3. -1 plus 3 is 2 pi over 6. Oh, now it's in the positives. That reduces, though, to pi over 3. Wait a second. I must have something calculated wrong. 2 pi over 6 pi over 3. Oh, dear. All right, let me pause it and figure out where my error is. I think it just hit me. I questioned it when I did this because 2 pi is the full circle, but we had already adjusted it by the 2 down to just pi. So pi needed to be splitting into 4 parts, which means each piece should have been adding pi over 4. So starting over here, this should have been pi over 4. This is even worse. So this should have been in 12. Oh, and I guess I could have looked in the book to maybe have helped me. Yes, okay. I'm just going to fix this though. All right, so pi over 4 should have been adding, common denominator would have been, I feel like I'm adjusting the wrong thing. Let me just start over here and not try to fix them over here. I'm going to pause the video, fix it, and then start it again. All right, yes, I have made it work, but it took me obviously a little bit of work to get there. Let me explain again exactly what we were doing, because I feel like we've made errors here. And this one is so much harder because it's in radian. If it were in degree, I don't think that we would have made our mistakes. So just to recap, -2 is the center line, 4 is the height, 4 things above is 2, and -6. Cosine means I'm going to be starting at the high point because this is positive. If it had been negative, I would have started at the low point. All right, the starting place is negative 2 pi over 3, and I did not know how many sections were in the negatives and how many sections were in the positives. I did know that I needed to take a full rotation of 2 pi and divide it by this 2, meaning that by the time I repeated, I would have used pi, and just for my mental sake, I was trying to do it in degree to get a visualization of where it needed to be. So by the time I've done this rotation, I have traveled 180 degrees or pi radians. Okay, so now that I knew that, to triple check myself, I took negative 2 pi over 3, and I was adding the pi, which needed the common denominator of 3, and so that gave me the pi over 3. So I knew that the ending place had to be pi over 3. It did the rotation in pi, so what I should have done was taken pi and divided it into the 4 sections. Now I'm adding pi over 4 each time. So my work here was to start with negative 2 pi over 3 and add pi over 4. Made a common denominator of 12. That answer was the negative 5 pi over 12. So I knew I had one more section in the negatives. Negative 5 pi over 12 plus the pi over 4 again. Common denominator of 12 got me 2, and that reduced to negative pi over 6. So that gave me another section in the negatives. Now these are not evenly spaced, of course, because I was having so much trouble. So this technically you need to fix. And so if you're not working in a pen, you can erase it and adjust it, but in this case, if I do that with the pen, I make things so much worse. Then I took my negative pi over 6. I again added pi over 4. Common denominator of 12 took me to pi over 12. Now I know I'm in the positive section. And one more time, just to make sure there's been no errors, I take the pi over 12 and I add the pi over 4, common denominator, took me to 4 pi over 12, which reduced to pi over 3, thankfully ending here. Again, my spacing's totally wrong. But I now know that I have 2 and a partial in the negatives and 1 and a partial in the positive side. Okay, so we know we're going down at the low point here, and I realize I'm over top of my other negative 6 numbers, then here and back up to the repeat by the time I get here. So this is not going to look like a nice curve because it should be evenly spaced. But there is the sections that they asked for sketching the graph. It just took a lot of paperwork because I couldn't do it necessarily on my calculator. I guess you could convert every time on the calculator, but either way you do it, to get the 4 sections labeled, it takes a bit of work.